Hi, I'd like to talk to you about what's going on midterm number 2 for spring 2016. First problem told you that the truth in a population, the true parameter was p equals 0.7. We test against a null hypothesis that the truth is a half, and we obtain a big p-value, which should suggest to us no evidence to doubt this particular wrong null hypothesis. And so since we have not figured out from the data that this null hypothesis is wrong, we're letting it go when it's wrong. That's one of the errors, and it is a type 2 error. So the correct answer should be B. In problem 2, we have a null hypothesis of mu equals 30. We get a t-statistic computed of negative 0.61, and we need to make a conclusion for this test, which means we need to use the t-table, table D, and look up a p-value. Since there are 19 observations, that means we need to use 18 degrees of freedom in the t-table. And so we would go to 18 degrees of freedom and look up a positive 1.61, which looks like it happens with upper tail probability between 0.05 and 0.10. And since it was a two-tailed test, that would need to be doubled. So the final p-value is somewhere between 0.1 and 0.2, and that's a huge p-value. The appropriate language would be that there's no evidence that the average differs from 30. So that would be E as a correct answer. On number 3, I'm asking you to use a confidence interval and make a conclusion using it. And if you have 64 items with a characteristic out of 100, that's a p-hat of 0.64. If you make a confidence interval for the underlying population proportion, you get a range between about 0.54 and 0.73. That means that if you go through your choices, option A is not true because 0.68 is a reasonable value according to this confidence interval, so you shouldn't conclude that it's different, that the proportion is different from 0.68, so A is a wrong answer. In B, since 0.62 is one of the reasonable values, we don't have reason to conclude that the interval and the population, we don't have any evidence that the population proportion is more than 0.62. We would say that B is correct if the whole interval was bigger than 0.62, and it isn't, so B is not right. In C, we would say that there's evidence that the interval is greater than 0.72 if the entire interval was bigger than 0.72, and we don't have that. So C is not correct either. In D, there is evidence that the proportion is less than 0.82, and since all the values in this confidence interval range for the population proportion are below 0.82, we know that's a correct statement. 3D is the correct answer. Problems 2 and problems 3 are worth 2 points apiece. In problem 4, you're asked about a sampling design. How is this being done? And you should recognize that there's a separate random sample done for each of the classrooms, and that is a description of stratified random sampling. There were a total of 6 points on this page. If you look down at your page total at the bottom, papers and students that are getting A's probably got between 5 and 6 points on this page. Students that were getting B's, sort of B performance on this page is probably 4 to 5, and then 4 and lower 2, 3, 4 is probably in the C range, and the D and F range is probably 0, 1, or 2. On page 2, the defect in the United States Census was undercoverage. The one we talked about in class was undercoverage, and that means that the sampling frame, how they do the survey based on housing units, omits transient and homeless people, and so they won't be represented in the census. That was 2 points. 1 point for coming up with undercoverage, the word, and 1 point for describing undercoverage. In problem 6, I wanted you to talk about the ways to reduce margin of error. That's the plus or minus part of the confidence interval, and you can reduce that by having more data, by having a lower confidence, a lower level of confidence. 90% confidence has a narrower, smaller margin of error than, say, 95 does. If you're doing a confidence interval for an average, you might be able to reduce the margin of error by reducing the variation sigma or S. So I wanted 2 of those 3 ways, 2 points total for that one. Problem 7, I tell you about a confidence interval, and then I want you to explain what 95% confidence means. The answer for 95% confidence has nothing to do with the interval that was provided. That's a distractor to catch people that don't really understand what they're doing. The question is referring to the 95% confidence idea, and that is talking about the overall reliability of the confidence interval method to produce intervals that contain the true parameter. And so it means that 95% of the intervals that you'll make using the confidence interval approach at 95% level will make intervals that catch the truth. 2 points for that one. 1 point was probably given for a partially right answer. In problem 8, a p-value is the probability of observing data or a test statistic like ours under the conditions of the null hypothesis. On the top of page 3, you're told about a quantitative data analysis. You can see that you're talking about insecticide concentrations. It's a quantitative variable, and you're given X bar values, S values. There's 150 fish, so there's a big sample size, and there were no outliers. That will come and be important later for a later question. I've given you the T multiplier for a 95% confidence interval, 149 degrees of freedom right here if you wanted to use it. If you went through the notes, you might realize that's T multiplier values for confidence intervals. If you use 100 degrees of freedom from the table, you might find that this number is helpful. The value here is S divided by the square root of n. This would save you some computation if you realized what that was. In 9a, you need to make a 95% confidence interval using the t-distribution, and that will be using x bar plus or minus one of these t multipliers. You could also go to the t multiplier in table D and look it up if you didn't realize that I'd given it to you. You'd go to 95% and use 100 degrees of freedom, 1.984 would be that value, and you should get a confidence interval of about 0.083 up to about 0.0993, with slight changes if you used a different multiplier, but there was 2 points for coming up with that interval. In 9b, since the confidence interval is all entirely above 0.08, and in 9b I'm asking you about whether the population mean mu could be less than 0.08. I look at the range that I computed in A and I see, oh, there's no reasonable way to think that mu would be below 0.08. The entire interval is above 0.08, so your answer needs to say that 0.08 is not a reasonable value. Values below 0.08 are not reasonable. The interval is entirely above 0.08, and that clearly tells us that a true value of mu below 0.08 ppm is not reasonable or plausible. That's 3 points. This is a pretty important question for going forward in this class. You need to be able to use confidence intervals to make decisions about things. 9C, do you think the salmon are safe to eat? The recommendation is 0.08 ppm or below, and because we have clear evidence that the typical concentration is higher than 0.08, we actually have evidence that they are unsafe to eat. So the right answer here, are they safe? You should definitely say that they are not safe to eat. So that would be B. No is the right answer. 1 point for that. In 9D, I'm asking you about trusting and being able to believe T confidence intervals or T-based methods. And we have way over 40 observations. We had 150. And we know we don't have to worry about outliers because the description said there were no outliers. T methods are okay here. The right answer for 9D is A. On the top of page 4, you get a problem about one sample proportion. There were 4,485 subjects. There were 1,296 of them that had an event. If you divide that out and use the prop test output, you'll see the p-hat is 0.28896 for that sample proportion. In 10A, you're asked to produce the confidence interval. The confidence interval is provided right here in the output, so hopefully, and most people did get the right confidence interval put in there for 1 point. In 10B, I want you to use that confidence interval and talk about whether the true proportion seems to differ from 0.35. And if you look at that range, you'll see it's entirely below 0.35, so the right thing to do here is to say that it does differ from 0.35 and that A should be the correct answer. 1 point for the right multiple choice. In 10C, I talk about doing a test and getting a p-value through simulation. We simulated many studies with 4,485 patients, and we simulated under the assumption that 20.2% would have a heart attack in 7 years. We simulated under that value because up in the problem description we know that 20.2% of type 2 diabetics will have a heart attack within 7 years. And so we'll simulate what the drug performance should be if it had a heart attack rate similar to just that for diabetics. And we found that our sample data, like what we got for Avandia, a p-hat like what was observed in the study, never happened in our simulation. So the p-value was 0, and that means that your conclusion would be that the data that was observed, the 1296 over 4485, that data was very weird and unusual to ever happen under the conditions of the null hypothesis. That means there's doubts about the null hypothesis, support for the alternative, that the proportion is different than for diabetics as a whole. And because our p-hat was much bigger than 0.202, we've got evidence that Avandia patients have a greater risk of heart attack than type 2 diabetics as a whole. There were 3 points for this answer. and you needed to give the direction. A lot of people were able to correctly say that the risk is different than 0.202, but they failed to say that the data gives clear evidence that the population risk for Avandia is higher than 0.202, and that needed to be part of your 3 points to get 3 points for the answer. On 10C, you got to look at your answer and make sure that you clearly said that not only was there a difference, but that the difference was that Avandia patients have a higher risk of heart attack. You got a 1 point deduction if that wasn't clear that you knew there was a higher risk. On problem 11 on page 5, there was a t-test about a quantitative variable, hours slept, and we wanted to know whether the average sleeping time mu differs from 8 hours. That's the alternative hypothesis, mu not equals 8. The null hypothesis would be that mu equals 8. The t-statistic was provided in the problem, negative 1.24. A lot of people decided they needed to compute this on their own. I don't know why. I'd given it to you, so shame on you for trying to compute something that I've already given you. The p-value would be to look up in the t-table for 1.24 for 21 degrees of freedom. And if you do that, 21 degrees of freedom, and it's 1.24, that means that your one-tail probability was between 0.1 and 0.15, and that means when you double it, because it was a two-sided test, you get a p-value between 0.2 and 0.3, and that means you have a big p-value conclusion statement. Data are compatible with the null hypothesis. There's no evidence to doubt the null hypothesis, and there's no reason to support the alternative. And the practical conclusion is there's no evidence that this average differs from 8 hours. A lot of people got into trouble on this question by concluding that this supported the null hypothesis somehow, or we had evidence against the alternative. All of those things are just terrible things to say. I've never ever said that in any problem, any notes. That's a fundamental misunderstanding that will continue to haunt you if you don't get it cleared up. A big p-value simply means that the data are compatible with the null hypothesis of 8 hours. It doesn't mean you've supported that idea or you've proven it. So make sure you get that worked out. That's a really deadly error that will continue to cause you trouble if you don't get that resolved. 5 points for that one. 2 points for, I believe, 2 points for the hypotheses and the p-value, and 3 points on the conclusion. On problem 12, we ask about a survey back in 2007 about approval for President Bush, and in 12A it says perform a z-based hypothesis test to determine if there's evidence that the proportion that approve of the president's performance differs from that of Richard Nixon during Watergate, and that approval was 0.27 at that time. So what we want to do is do a hypothesis of null hypothesis p equals 0.27 for the George Bush period, because that's the value that was in place for Nixon back in the 70s. And the alternative hypothesis is that p is different than 0.27. You should probably go ahead and compute this z-statistic using the p hat from the data, 0.2995 something. Subtract off 0.27, divide according to the z-statistic formula, and get 2.23. If you were clever, you could go up and square root this x squared, like I talked about in the notes. The p-value is correctly done right here in the output, or you could have tried to look it up yourself. A lot of people got points off on the p-value because they only looked up one of the tails, and it's a two-tailed lookup, so one tail looking it up gives you 0.0129 for one tail probability. When you double it to get the second tail, you get a p-value of 0.0258. If you were using the tables, if you use the online output, you get 0.2555 or so. This means that the data are incompatible with the null hypothesis. There's evidence for the alternative, and there's evidence that the proportion for Bush differs from that of Nixon. How does it differ? Because the p-hat for Bush is 0.29, 0.3 roughly, and that's bigger than it is for the Nixon years when he had 0.27. There's evidence that the approval for President Bush is greater than that for Nixon. That was a 5-point problem. Again, 3 points for the conclusion, 2 points for the other items. In 12B, I was asking you about the validity conditions for the test, and a lot of people mistakenly gave me the validity conditions for the confidence interval. For the test, you need to have expected events more than 10 and expected non-events more than 10, and that would mean that the expected amount under the null hypothesis was 27%. We had 1,125 subjects, so the expected number of events was 303, almost 304. That's clearly bigger than 10. The expected number of non-events would be 1 minus p naught times n, and that is clearly more than 10 non-events. So that means the validity conditions for using a z-test have been met. A lot of people just said there were more than 10 events and 10 non-events, and that's the confidence interval conditions. This was the test conditions I asked you about, so you probably only got 1 point if you used the confidence interval conditions. To get 2 points, you needed to use the test conditions. On the next and last page, problem 13, we want to know whether the population proportion supporting Sanders differs from 0.5. That would be a null hypothesis that p is 0.5, and the alternative is that p is not equal to 0.5. That was 1 point for that. For the margin of error, getting a confidence interval to have 4 percentage points, that's an m of 0.04. And so we would need to plug into the sample size formula for a proportion. A lot of people tried to use the sample size formula for an average, and that doesn't work. You need to use the formula for a proportion, and it would be 1.96 for the multiplier divided by the margin of error m of 0.04. That would get squared, and then you'd multiply by a p star of 0.5 and a 1 minus p star of 1 minus 0.5. And we used p star here because we had no previous information provided about what the proportion for Sanders would be. So in absence of any information about the truth, you put in 0.5 as I suggested in the notes. That gives you a computation value of 600.25 observations. You need to round up to the next whole number for 601. 2 points for that. In 13C, we do a test, and we get a z-statistic of 0.72. We need to get the p-value, and because it was a two-sided test, we need to look up the probability of something more extreme than 0.72 greater and more negative than negative 0.72, and the final probability for that total is 0.4716. Data are compatible with the null hypothesis, and that means there's evidently no evidence to suggest that the proportion supporting Sanders is different than 0.5. Again, the same problems of students trying to conclude that this means the proportion is 0.5, saying that you have evidence to support the null hypothesis, or saying that you have evidence against the alternative is sheer madness, and nothing good will happen to you if you say such things. So please try to stop it and have me help you get cleared up about what to say about these things. This was a 4-point problem, 1 point about the p-value and 3 points about the conclusion. That wraps up the exam. Please let me know if you have questions. The most important things to worry about are getting confidence intervals concluded correctly and making sure you understand what big and small p-values allow you to conclude.